Hi, everyone. We are thrilled to welcome back Jonathan Ballon, Vice President at Intel Corporation. Jonathan has been a leader in IoT since the very beginning in senior roles at Intel, General Electric, and Cisco. Jonathan also serves as an advisor and board member to several Silicon Valley startups and accelerators, as well as the advisory board for IoT Solutions World Congress. And he's here today to talk about how AI is transforming IoT. With that, let's get started.
Living on the edge. For some, it's a phrase that conjures up an uncomfortable sense of risk and uncertainty. For others, it represents the only sure path to experience life's full potential. But when it comes to the impact of artificial intelligence on the future of IoT, there's really only one way to look at it. The edge is where the action is. It's the edge where unprecedented amounts of data will not only be generated and collected, but where the critical decisions directing autonomous vehicles and devices must be determined in a matter of milliseconds. Where businesses and enterprises worldwide will seek to carve out their own unique competitive advantages with the power of data. And while the immense value of the data center will continue to grow for decades to come, many of AI's most promising contributions to the IoT revolution will require the development and distribution of specialized compute resources. Resources designed to enable an exciting new era of opportunity and growth for businesses everywhere, and built right into the farthest reaches of the network and its ever-expanding edge. Which is exactly why you can find Intel there today. Living on the edge, it's not for the faint of heart. It's a place we usually associate with risk takers and thrill seekers. A place that tends to attract the kind of person who tends to look at life a little differently and its potential to offer amazing experiences. Well, it turns out there are some really interesting parallels between that type of metaphorical living on the edge and the incredibly exciting developments that are taking place at the edge of the IoT network infrastructure. So I'm here today to invite each and every one of you to join me out on the edge. Now, the good news is the type of edge that I'm talking about doesn't involve jumping out of an airplane or off the side of a mountain, but it does involve taking a leap that promises to dramatically accelerate the advancement of every industry and our ability to deliver on the true promise of IoT. I've had the opportunity to present at this conference for the last several years. In 2014, I asked you to believe the hype. This thing called IoT really was going to transform the world in all kinds of profound ways. In year 2, I described the journey we as an industry would need to take in order to begin to achieve the full potential of IoT. That journey started with connecting the unconnected and getting access to data. 2016 was the year I focused on a number of real-world deployments that were leading the way from hype to reality as companies scale deployments of intelligent systems. And finally, last year, I shared a variety of use cases where Intel and our partners were already scaling to win by taking advantage of the Market-Ready Solution ecosystem program that we launched. This year, I have a different message. None of that matters. That's right. Forget about what I've told you the last 4 years. None of it matters anymore. And I'm at least half serious. Why? Because in the past 12 months, the game has changed. The impact of recent developments in artificial intelligence are going to be so profound for IoT and accelerate its potential so quickly that it's almost like a new beginning for the entire industry. Don't get me wrong, we haven't been wasting our time or going down the wrong path. It's just that AI changes everything in terms of how we move forward from here. AI not only punctuates the economic value of large-scale IoT deployments, it calls for the accelerated design and distributed computing networks that allow for a virtuous cycle of value creation. Which brings us back to the edge. Because when it comes to implementing many of the most promising applications for AI and IoT, the edge is quite literally where the action is. It's where the data is generated, captured, stored, and processed. And while the data center will absolutely retain its foundational role in the IoT infrastructure, it's becoming clear that many of these breakthrough AI applications will require decentralized computing resources so that value is not exclusively created in the cloud, but across a cloud-to-device architecture. Autonomous vehicles and devices, for instance. Safe, reliable autonomy in mechanical systems isn't something that's created by the simple accumulation of data. Autonomy is created by the ability to use that data to inform critical decisions. And in many of the autonomous devices, those decisions need to be made in milliseconds in order to be of any use. These systems need access to powerful compute resources that offer all of the advantages and innovations of a modern data center, but are located closer to and focused more narrowly upon the needs of that particular system. Failure is not an option, and that means latency is not an option. The volume of data, velocity of data, and variety of data all demand it. So with that in mind, I'd like to spend the rest of my time today talking a bit about how the value of edge will rise from dumb data source to the hub of inference and autonomy to better facilitate this game-changing acceleration that AI will bring to the Internet of Things. Let's get started. But first, I'll say it one more time. The edge is quite literally where the action is. So over the last couple of years, I've introduced almost like a scorecard for us to gauge how we're doing as an industry, and I've focused it on things that are environmental in the market for IoT. And we typically do this across three vectors: business, people, and technology. And this year is no different, except with this year, I thought we would apply an AI lens onto some of these metrics to get an idea of how impactful AI is playing on the world and on the Internet of Things. So let's take a look. First, there was a great report that came out just recently in the last couple of weeks from the McKinsey Global Institute that estimates that over the next 12 years, there will be $13 trillion worth of economic value created through AI technologies. And if you would apply that on a global scale, that works out to about 1.2 points of GDP growth annually over that period of time, which is an extraordinary amount of value creation. There's been a big debate about AI and its potential to possibly impact the job market, and this has been a debate that's been going on for well over a decade. And what's interesting is that one of the most credible sources for these types of analysis recently published their findings, which is the World Economic Forum, and according to their belief, machines will actually create jobs over the next 15 years. In fact, they believe that 58 million jobs will be created over the next decade and a half. The question is, will we have enough talent to support that level of job growth? If you look at this chart, the total market for AI is general purpose. 84% of AI jobs are general purpose, while only 16% are focused on the AI market. We actually believe that the majority of AI growth will actually occur at the edge of the network. So this is clearly a market shortage, and it's represented by the fact that kids coming right out of university are commanding, on average, $300,000 a year for AI specialists that are joining major tech firms. So if you flash back maybe 7 years ago, we were using the same metrics to talk about data scientists as being the most valuable resource in tech. Today, it's AI. And what's interesting about how AI is being applied to these markets, the majority, in fact, 2/3 of the value that's created by AI is actually applying AI techniques to already existing big data applications. And you can see here listed by industry the impact that AI will have on a lot of these existing use cases. But one area that I find particularly interesting within that category is the market for computer vision and deep learning. And this is where we're using cameras and imaging and vision systems to get an even deeper level of understanding of our physical world. In fact, we believe that over the next decade, over half of the market for AI will be in software generated for the computer vision market. And you can see here how large, in fact, those markets are. So to summarize our market indicators, AI is creating an immense amount of economic value. It's driving job creation and creating value through computer vision use cases. And I want to talk a little bit about computer vision and how that's transforming every industry. Take a look at retail. Cameras are now being used in stores to create a similar type of experience that you have online in the real world. So cameras over the last several years have been used to understand how consumers walk through a physical environment and inform merchandising decisions. They were also being used to look at shelves to understand what products are on those shelves. Are the inventory levels running low? Are the products miscategorized? But over the last year and a half, we're starting to see cameras being used to deliver a level of personalization and automation in the retail store. You may have heard in the US that Amazon has launched their Go stores. These stores are basically intended to allow you to replicate the same experience you have online with Amazon in a physical store, where you walk in, they know who you are, they understand your preferences, you can grab products right off the shelf and simply walk out. They call it frictionless retail, and it's not limited to Amazon. This is also happening in China with companies like JD.com that have plans to launch over 1 million of these stores in the next coming years. We'll talk about some examples in detail that are happening in industrial and smart cities and healthcare, but let me tell you a little bit about what's happening in transportation. Algorithms based on computer vision are going in vehicle, in cabin, both in cars and in trucks, and can understand gaze control. So the algorithms can understand if a driver is getting drowsy and falling asleep and deliver an alert. They can even understand if you're getting distracted and looking at your phone and give you an alert. Cameras are also going into light rail transit so that they can understand ridership and see and count the demographics and the number of people that are actually riding light rail transit and buses in urban environments. And what they do with that information is they can inform the routing tables so that they can better optimize the movement of people around the city. What's enabling this for a lot of our customers is a software toolkit that we launched in the beginning of June called Openvino. And Openvino is a way to allow developers to very quickly deploy these types of applications across any industry. What it does is it allows a developer to be independent of the of the hardware choices that they make, and allow them to optimize the resources in a CPU to get orders of magnitude better performance at a fraction of the cost of traditional methods. So with this particular toolkit, the Vino does not stand for wine, I'm sorry to say, but it does stand for visual inference and neural network optimization. And the open piece of the name refers to the fact that we will open source this year and make it available to the developer ecosystem to take control of this toolkit and realize its even fuller potential. The toolkit allows you to actually separate the cores in a particular CPU and optimize those cores for various application tasks, as well as offload inference capability to an integrated GPU. And this is delivering tremendous levels of performance improvements over a traditional standalone GPU method at much lower costs. But if you need even more performance, we're offering this with accelerator technologies, such as a low-power, high-performance vision processing unit, such as the Movidius Myriad product line, or an FPGA, such as an Area from Altera, now part of Intel. So the way this works is we've got a deep learning toolkit, and this allows developers to really leverage whatever frameworks they're already comfortable developing in. It's agnostic to TensorFlow, ONNX, MXNet, PyTorch. Any framework that you're comfortable writing in is supported by this model. In addition, we support over 100 networks in the tool today, and there's more networks being added in every release. We're releasing on about a 2 to 3 month schedule. We've also included a set of base-level CV algorithms, everything from object detection, object tracking, facial recognition, a variety of behavioral types of algorithms to make it very easy for a developer to start getting productive very quickly. And the key, two keys to the toolkit are really the model optimizer, which allows you to import and optimize your network for target hardware platforms, as well as the inference engine, which is a single API and runtime for neural network optimization. These two things are the workhorse, and they're some of the reasons we're getting such breakthrough performance, which I'm going to share with you in a moment. But if you're still working in standard computer vision methods, we support that as well, with full integration of OpenCV, OpenCL, and OpenVX, and all of the libraries and APIs that they offer. So again, this is completely agnostic to your framework. It's complementary. It will be open source this year and allows for cross-platform flexibility. It's actually part of a broader portfolio of AI tools that we offer at Intel. If you're a library developer and you're operating a very deep level of programmability, compiling and leveraging primitives, we can support that level of programmability. If you're a data scientist and you're working more at the framework level and need access to libraries, we can support that. But for the application developer, this allows you to operate at a level that is abstracted from the silicon. So you don't have to be a silicon engineer to be able to optimize those resources to get the type of performance gains that you're looking for. One company that has been leveraging Openvino is GE Healthcare. This is an example of AI in production. This is a real deployed solution where they're working on more accurate medical diagnoses. So you may think of computer vision as applied to video streams, but image analytics is also a ripe use case for this type of tool set. And you can imagine in medical imaging, these are very dense, very rich images that are taken of your body. It could be an MRI, a CAT scan, a PET scan, a sonogram, a mammogram, or even an X-ray. And what GE does is they leverage very high-performance ZN processors in their imaging equipment. These are the same types of processors that are used in data centers. And the reason they do that is because when you can take an image of a patient quickly using a high-performance compute platform, what that means is that you're reducing the amount of radiation that is exposed to that patient. So this has a tremendous impact on the actual patient experience because they're in these tubes for less time and receiving a lower dose of radiation. With the leverage of Openvino to optimize the inference of that image, GE was able to get 14 times performance improvement on that image analytic workload. By doing so, they were able to reduce the total cost of ownership for these platforms by 25%. Less time to take an image, less time to get the diagnosis or the reading of that image means more radiation time and more CT or MRI equipment time that's available for other patients. Here's an example that I like a lot. Alibaba, cloud service provider in China, obviously. And what they're using Openvino for is for automating a lot of factories that are in their supply chain. Now, you may be wondering why Alibaba would be bringing Ali Cloud capabilities and their Ali OS into a factory, but when you think about it, Alibaba actually has 60,000 factories that are part of their supply chain. In some cases, these are factories that provide product to Alibaba. In other cases, they're part of a factory network in China. And there is such a tremendous amount of opportunity through China's Manufacturing 2025 program to actually leapfrog what's happening in other parts of the world and move away from a highly labor-intensive manufacturing process into one that's more automated. And this is especially true because in China, they're seeing an aging workforce. They're going to have over a billion people of retirement age in the next decade. So the ability to introduce factory automation is really important, not only for productivity, but also for product quality. So you're probably wondering what you're seeing in this video, and what you're looking at is a before and after of a single factory that we automated with Alibaba in Chongqing. This is a Yume factory that manufactures transmission casings for a very large automobile manufacturer. And what happens is this aluminum gets poured into a casing die. It's exceptionally hot. A robot pulls it out, cools it in some water. And what was happening before is that a single worker, after that part was cool, would physically inspect it, as you see him doing here, looking for 4 known defects. Now, this guy's a professional, has been doing this for a long time, but he's not as good as the computer. He can only spot 1 out of every 5 defects. So he gets 20% of the defects correctly. What we did was we implemented an automated robot with computer vision that can now take hot parts out of that casting die and very quickly point all 4 of those known defect areas to a camera. And for 1 defect, the robot with computer vision can spot 99.4% of the defects, which is pretty good. For the other 3 defects, the robot can spot 100% of the defects. So this is having a tremendous impact on the quality of parts that are coming out of this factory and the rework that would have to take place prior. It also has, obviously, a tremendous impact on the productivity and the amount of parts that they can put through the entire factory. This has been so successful that it's being rolled out to factories across China. And what I thought we would do is invite Chet Hullum, who's the general manager of product management for our industrial division at IoT at Intel, to tell us a little bit more about what we're doing with Alibaba in China. Chet. How you doing?
Good to see you.
Thanks for coming. I noticed that you brought a robot with you.
Yeah.
I don't know how you got that on your check-in, but can you maybe give us
Absolutely.
Give us a demo of what we're doing over here?
Absolutely.
That'd be great.
Let's take a look at it. So what we have here is very similar to what we've done in deployment. This is an ABB IRB 1600 industrial robot. This robot has 50% shorter cycles and one of the highest performing robots in its class in the market today. It's holding 2 aluminum cast parts, one that has several defects and one that is defect free. And then here you'll see we have an HD camera with an LED backlight, and all of that is being fed into our ruggedized industrial IPC that is supplied by our partner IEI, and on that we're running the Intel and Alibaba Edge Compute platform, and also the deep learning algorithms that are optimized on Openvino.
So Chet, for folks in the audience, can you explain why do we need a ruggedized PC in this use case?
Yeah, good point. In a lot of the factory deployments we deploy, we need advanced computing power, but also we're deploying in very harsh environments. And in many cases, we need fanless capability because of debris and other things in the air. We have to operate in ambient conditions that are 95% humidity or 100 degrees Fahrenheit or 37 degrees Celsius in ambient temperatures.
So you can't have a fan because you can possibly have a fire. Is that right?
That's right, exactly.
So not a good use case for a GPU because most GPUs require a fan.
Yes, most GPUs do, and so this gives them a flexibility to get that computing power, yet operate in a fanless environment.
I think that's super important. I think a lot of people don't realize that when you're performing, high performance compute at the edge on-prem, power consumption is a huge variable that needs to be managed.
Yes, absolutely.
So should we get the factory started?
Yeah, let's do it.
Let's start the factory and take a look.
Okay, so here what you see is the robot is shifting between the good part and the bad part. And on the screen, you'll see in the green bounding boxes the actual defects or anomaly detection that the camera is able to pick up. With this optimization, the IEI is running a Kaby Lake Core i7, again with our deep learning algorithms optimized on Openvino. We're able to see a 50x increase in the amount of images we're able to process, which is about 300 images per second.
So that's more images per second than probably the robot can even
exactly.
put in front of the camera.
We're only limited by the speed of the robot.
All right, very good. So this is deployed today?
Absolutely. So this demo is not just a demo for showing purposes here. This actually is what we've deployed in over 20 factories across China with our partners, Alibaba. And you saw in the video at the Yumei facility, they were able to see a 5x increase in accuracy detection by switching from the manual process to the vision-based deep learning process that we've been able to deploy with Openvino.
Very cool. Mm-hmm. So all of this is available today?
Absolutely. The robots that you see here, the ruggedized industrial IPC is available today, and of course, the Intel Alibaba Edge Compute Platform optimized deep learning algorithms on Openvino will be available today.
It's an exciting announcement.
Yeah.
Thanks, Chad. I really appreciate you coming.
Absolutely. No problem. Thanks.
All right. Take care. So that's a great example, I think, of a customer and partner leveraging Openvino to just get orders of magnitude better performance, and it's driving a real business outcome for these factories. In fact, the only limit to our scaling of this solution are the systems integration resources across the country to do the implementation. But with Alibaba's 60,000 factories, you can imagine that this same type of solution is not just limited to machine parts. It can be used for anything in their supply chain. Any product that's being manufactured could use a similar type of defect identification. So what's clear, our partners are using Openvino, and the software is great, but we also have some new hardware accelerators to share with you today as well. So you may have heard of the Movidius Myriad product line. This is something that we are now on our third generation of the Myriad line. This is Myriad X, and this little 8x8 millimeter package can deliver over 4 trillion operations per second, leveraging less than 2 watts of power. So when you're delivering things at the edge, whether it be on a camera, on a ruggedized PC or something like that, power consumption and size are hugely important, which is why things like Movidius and other packages from Intel are super important. So one Intel Myriad X is great, but 2 Myriad X is even better. And the only thing better than 2 Myriad X is 8. And so what we're announcing today are Intel Vision Accelerator cards. I happen to have one right here, color coordinated with my outfit, if I can get it out of my jacket. This is a Myriad X-based Vision Accelerator card. This has 8 Myriad X VPUs on it, on an integrated card. And this delivers extraordinary scalability and performance for anyone that's deploying a vision-based system like the one we just saw. So this will be available in a variety of form factors. This one is a PCIe I/O, but we also have this in mini PCIe and M.2. These are available today through our partner ecosystem, which I will share with you in a few minutes. But if you need more performance than what this offers, which is 32 trillion operations per second, we actually have a second version of the card, which is based on an FPGA, an ARIA 10, and that is, you see on the right side of the chart, also in the same form factors. And these all have deep learning algorithm portability using OpenVKnow. And the performance is pretty amazing. Let's take a look. So on the far left, you see the same board that I just held up compared to our leading competitor, and we're getting 3x better performance measured by inference per watt per dollar, which is really, if you're doing apples to apples comparisons of AI and deep learning workloads, this is the metric you want to pay attention to. Inference performance per dollar per watt. If you were to use the smaller version of the card that I just showed you, which only has 2 Myriad X VPUs, we're seeing about a 20% improvement in terms of inference per watt per dollar. And for that FPGA version, almost 2x. What you see at the bottom of the chart is some of our launch partners for these Vision Accelerator designs. These are committed to supporting these products. Several of you are here in the audience today, and as you can see, we have everything from equipment builders to OEMs, ISVs, and cloud service providers. So I thought, due to the important role that cloud service providers are playing in the future of IoT, I thought we would dig a little bit deeper on them. Because it was a couple years ago where Amazon Web Services announced Greengrass. And that was the beginning that led to Microsoft, Azure, IoT, and others to follow suit, where they are basically bringing cloud service functionality out into on-prem deployments. And to me, this is some of the most underreported news in tech. When the largest cloud service providers in the world are moving cloud functionality to the edge, on-prem, to allow for asynchronous and decentralized computing, this is a great indicator that this distributed computing architecture from device to cloud is becoming real. In the case of Microsoft, they're focusing on industrial workloads with computer vision. So Azure is today delivering over 2 trillion messages a day because of this enormous install base of industrial PCs that they have. And what they're doing is converging various applications onto common compute platforms. So it allows them to actually get higher performance compute, move various applications, could be PLC, an HMI, a computer vision system, onto one platform, which gives them higher level of performance, actually get to lower their BOM cost in doing so, and it creates headroom for things like deep learning applications. So now they can deploy optimized models using these Vision Accelerator designs into these existing environments. Another example I like a lot is AWS. They're focused on factory safety. This is becoming even more of a critical issue because more and more factory automation devices and robots are moving into these environments, and it's important that we keep workers safe. So here's another example of AI in production where AWS and Greengrass have partnered with us on these Vision Accelerator designs to allow for the automated visualization of worker safety gear. Are they wearing the appropriate gear? It could be a mask, it could be goggles, it could be a hard hat, it could be a particular vest. All of that done through computer vision and preventing people from entering a dangerous area if they're not properly equipped. It also allows robot avoidance, so you can put cameras into a factory floor and those cameras can detect when people are moving too close to the robots, and it can either send an alert or pause the robotic movement. Great example here of computer vision doing good for workers and companies. Here's how it works. So today, you could take a similar industrial PC like the IEI tank that we just showed for the Alibaba example, and leveraging Openvino and our factory worker safety monitoring app, you can basically leverage AWS Lambda functions to perform that analytic on the edge asynchronously. In this particular example, you would be able to use 2 cameras and be able to view those two streams simultaneously. With the Vision Accelerator card that I just showed you, one card expands that system from 2 HD cameras to 16. So you're getting 8 times the video processing capability, which leads to an 80% savings in hardware costs. Rather than having to deploy another full system, you can expand this out, only limited by the number of slots in that edge server. So great example there with AWS. Smart cities are no stranger to video analytics. We've been keeping our communities safe, using cameras for traffic and parking for years. And what's happening over the last several years is now that we're getting deep learning capabilities, we have the ability to learn and build dynamic systems. And companies like Dell and others are building all of the equipment to support this at the edge out in these urban environments. And ISVs like Agent VI are using this to identify available parking spots, to inform emergency response services, and of course preventing crime. And I thought I'd like to invite on stage the co-founder and CTO of Agent VI's, Vika Ashani, to tell us a little bit about how they're leveraging Openvino and the Vision Accelerator designs in their business. Vika.
Hi, Jonathan. Great to be here.
Thanks for coming. We're glad to have you.
Thank you. As you know, Agent VI is one of the leading providers of video analytics solutions, and we've been providing our solutions to cities and enterprises all over the world for more than 15 years. And today I'd like to talk about our cloud-based platform called Innovi. Innovi is the platform that we use for delivering video analytics powered by AI to cities. And Innovi employs a distributed processing structure where we're deploying Intel-based appliances to the edge, to the user's network, and using those appliances to connect the networks to our service. Recently, we've been able to integrate these appliances with OpenVino to perform deep learning inference at the edge. And we've been able to get a 5x improvement in camera capacity using the exact same hardware.
Same hardware, 5 times improvement just using the software tools. That's
correct.
Pretty impressive.
Yep.
Can we maybe show them an example?
Sure.
Okay.
So the first use case I'd like to talk about is something that we did jointly with the city of Tel Aviv in Israel. And their sanitation department wanted to improve the efficiency and response time of garbage collection from streets in the city. And they wanted to use existing surveillance cameras to do that. So the solution that we came up with was to use Innovi's custom detection capability. And what we did is we collected images from the city, and then we used those to train a deep learning model that is able to detect piles of garbage. We then deployed that model to various cameras in the city, and whenever a pile of garbage is detected, an alert is issued.
So when you used Openvino and you said you got 5 times improvement, what capabilities does that allow you to deliver then to the customer?
Well, basically, it allows us to deploy less hardware and get the same number of cameras, and that in turn translates to savings for our customers and an improved ROI.
Cool. Can we look at another example?
Sure.
All right.
So our second example has to do with anomaly detection. And cities are deploying huge numbers of cameras, and in most cases, they don't really know what to do with these cameras, what to search for, what to detect. So there is a great need for creating a system that performs autonomous detection. And what we've come up with is the idea of doing anomaly detection. So the way this works is we actually collect data from each of these cameras over a period of a few weeks, and then we build a model of normal behavior, different days of the week, different times of the day, and so on. And then that model is used in real time, comparing the actual events and trying to find any event that deviates from the learned model. So we can actually see 2 examples on the screen. On the left, we can see a van at night parked in an alleyway and a person getting out of that van. And since that does not match any learned event, an alert was triggered in that case. And on the right, we're actually seeing 2 people in a parking garage at night mock fighting. And again, this does not match any learned behavior. So in this case also, an alert was triggered.
That's great. So the more data you have, the more you inform your model, the better your behavioral algorithms are, and
Correct.
the more you have a more robust anomaly detection, right?
Right.
So that's great that you used Openvino to help with that scalability, but we also gave you access to some of the Vision Accelerator cards that you've had, I think, just for a few weeks.
Correct.
How has that had an impact on these types of solutions?
Well, as you mentioned, we only had these for a few weeks, but because of the easy portability of Openvino, we actually managed to take our application that was running on the embedded GPU and port it to the new hardware in literally a matter of a couple of days. And initial benchmarks gave us an additional 2x improvement over the 5x improvement we already
So
had.
10x improvement overall.
Correct.
Combining the toolkit with the new hardware. That's fantastic.
Exactly.
Zvika, thank you very much for your business and for joining us today. Thank you. That was Agent VI and their partner Dell EMC, leveraging the full suite of offerings that we have in the computer vision portfolio at Intel. You know, AI in production is not limited to these one-off use cases. We actually have built an entire program. It's a single pane of glass into our ecosystem, our technology portfolio, and our experts. So this is a program, AI in production. We're announcing it and launching it today. You can see at the top of the page the URL where you can get more information. And regardless of where you sit in the ecosystem, if you're a solution builder, this gives you the ability to find partners so that you can reduce your complexity. Because as you've heard today, IoT and AI is a team sport. It requires many partners in the ecosystem to come together to really deliver an end-to-end solution. If you're an end user, this is where you can go to find experts and technology to accelerate your deployments. And if you're a computer vision algorithm developer or an equipment builder, you can partner with Intel. And this is a single place where you can go to get access to co-marketing and co-selling with us through this program. Last year, I talked to you about our market-ready solutions initiative. And the idea behind market-ready solutions was exactly to solve this problem of bespoke implementations that didn't scale. So what we endeavored to do is to bring our ecosystem together around very specific use cases and to bring all the hardware, software, and services together into a prepackaged, pre-integrated, and deployed solution offering that then could very quickly accelerate the time to value for end users. And I'm really pleased to share with you today, 1 year in, we have well over 100 solutions as of the midpoint of this year in the program. These have generated over 20 million marketing impressions in the IoT ecosystem with over 10,000 leads that we've delivered to our ecosystem for follow-up. These solutions have been deployed a minimum of 1 time, but in total, we've deployed over 400 of these, and this is data as of the end of June. We're just seeing a continued acceleration of this. In fact, 57% of these deployments are repeat deployments. We have some of these solutions that have been deployed dozens of times that are doing extremely well. As you can see, they span every market. We're focusing on the highest value use cases, and we think this program's a winner, and we're going to continue to invest in our ecosystem and invest in this program. If you want to learn more about what's happening in computer vision and AI and IoT, we've focused our booth this year really on those kind of leading edge use cases. So you're going to see examples of market-ready solutions that are ready to be deployed through our partner ecosystem. You can see examples here on the screen of partners that we have in our booth and the myriad ways that computer vision is being deployed. So to repeat one more time, when it comes to AI, the edge is where the action is. And Intel's there, and we're ready to support you and help you smoothly navigate this leap. So I want to thank you for your attention this morning, and I look forward to seeing you at the rest of the show. Thank you.